Hello, hi everyone, good afternoon. So today we are going to study one of the most important concept in mirrors, that is a sign convention. And why it is important? Because it is not that difficult, but you guys very confused. This topic is very confusing. Lot of you will get confused for sure, right? So that is why pay attention. If you learn this sign convention for the spherical mirrors, it is exact sign convention you will use for the spherical lens. And then once the sign convention is clear, you can solve all the numerical questions from this chapter. So welcome all, welcome to our channel Pioneer, and let's begin. Hi Niharika Reddy, good evening. Hi ASR 95, hi. All right. So okay, let me choose a color. So this is about me. If anyone is seeing me for the first time, this is about me. Hi Rakshana, nice to see you, good evening. All right, so the important topic sign convention, आप सबको पता है इसके बारे में, but you might get confused, so pay attention very carefully, very important. So now, do you know Cartesian rules? Cartesian coordinates. So in Cartesian coordinate, the horizontal line, this line is our x axis and this vertical line is our y axis. These are Cartesian rules, right? So on the Cartesian rule, this point here, there is a cross section of the y axis and x axis. This is our origin. If you go towards right of the origin, there is a positive direction. So positive x values, and this is the negative direction. Correct? If you go upwards, so that would be positive. If you go down, this would be negative. So all of you know this, है ना? आप सबको पता है x axis में अगर right side में जाएंगे तो this is a positive direction, left side में जाएंगे this is a negative direction. अगर ऊपर जाओगे x axis के ऊपर, so y coordinate जो होता है वो positive होता है, x axis के नीचे y coordinate negative होता है. ये अगर सबको समझ में आया आप अभी, the positive direction side of the incident ray. Okay, Niharika, give me 2 minutes, I'll explain. So now हमारे पास दो टाइप के मिरर है. आपको पता है कौन से दो मिरर्स है? Concave mirror and convex mirror. So you can draw, this one is a concave mirror and this is our principal axis, है ना? There is a principal axis. There is a concave mirror. Then another mirror. So this one is the convex mirror and this is the principal axis, right? So now this point is the pole. Do you remember this point is our pole? So this pole will act like a origin. Pole क्या है दोनों mirrors में? It is the origin. What is this principal axis? Principal axis is nothing but similar to this x axis. Now what you do is draw an imaginary line here which is perpendicular to the principal axis. दिख रहा है सबको? This imaginary line, this will act like our y axis. Similarly, draw another imaginary line here. So this will act like our y axis. Again, use the same rules. So what are the rules? Go to the positive direction. So that is right of the pole. So this is positive. If you go to the left of the pole, it is negative. If you go up, positive. If you go down, negative. Same, if you go to the right, positive. Come to the left, negative. Then go up, positive. Go down, negative. But what are these? What are these positive and negative? So what do you measure? Is this clear, everyone? Whatever I have written, is this clear? Any questions until now? So now I need some space. I'll remove this. This y-axis I'll remove. Okay, this instead of the x-axis I'll write here the principal axis. So now this line is the principal axis. There is a pole. Okay, this one is the pole. There is a principal axis. So what do you measure along the principal axis? What properties or what physical quantities you measure along the principal axis? There are three properties, that is u, v and f. What is u? U is the object distance, v is the image distance, f is the focal length. And all these quantities you measure from the pole, because pole is the center. So if you place the object here, there is your object. So this would be this is the u, which is the object distance. If let's suppose image is formed here, there is the image. So this would be our image distance. V is the image distance, u is the object distance, f is the focal length, right? So now this u here, object distance is going to be negative, because you are going to the negative direction. You are measuring it to the negative direction. So u is negative. In this case, v is positive. Understood? V you are measuring to the right side. Clear? And if the object is above the principal axis, so this object, it will have height of the object, it is above the principal axis, so it would be positive. If it is below, if let's suppose the image or the object is below the principal axis, that is going to be negative. Clear? Easy? So now there are some rules which you should know. Object is always placed left of the mirror. So now if it is a concave mirror, this is where you place the object. This is the object. If it is there is a concave mirror. If it is a convex mirror, again there is a principal axis. Again you place this object. But object you can place below as well, right? There is no such thing that object should always be above. Object can be below the principal axis as well, but it has to be on the left side in both the cases. Then the second one, light from the object fall left to right. So that is the direction of the light. This is the direction of light from left to right. Light is always going from the left to right and is falling on the mirror. So there is a direction of light. Okay, there is the incident rays. Then all the distances parallel to the principal axis measured from pole. So this point here is our pole. So I told you pole is like a origin, like a center. So you measure all the distances along the principal axis, which is u, v and f, measure from the pole. Principal axis is taken as the x-axis, right? These are the sign conventions. Yeah, there is a summary. From the pole, if you go to the right side, it is positive. You come to the left side, there is negative. This is the direction of the incident rays. If you go up, so upwards positive, downwards negative. So these are the sign conventions you need to remember. If you learn this, that's it. Everything else you can solve just by learning these sign conventions. Now, why these sign conventions are so important? Because we can use this formula. So what is this formula? This is called as mirror formula. This formula 1 by v. What is v? V is the image distance, u is the object distance, f is the focal length. If you want to use this formula, your sign convention has to be correct. Then only you can use this formula. And in this case, because we keep the object always on the left, so u is negative always, right? So let's suppose this is your concave mirror, this is the object, so this distance is your u. U is always going to be negative. Now, how the focal length? Let's suppose how the focal length is defined. There is a concave mirror. If the rays parallel to the principal axis fall onto this mirror, what will happen? They will converge at a point. So there is a focus, there is a pole. So you measure the focal length, there is a focal length. You measure the focal length on the left. So focal length for the concave mirror is negative. For the concave mirror, focal length is negative. And if it is a convex mirror, there is a convex mirror. So there is a convex mirror. All the rays which are parallel to principal axis, they will diverge. They will diverge something like this. And they appear to diverge from this focus. So there is a pole. So you measure the focal length on the right. So you go to the right of the pole. So focal length for the convex mirror is positive. Clear? If you know this, then you can use this formula. If it is a concave mirror, this focal length, you should use the negative sign. If it is a convex mirror, this focal length, you should use positive sign. So let's solve some questions based on this. So you will understand why the sign conventions and the mirror equation is so much important. Alright, solve this question, everyone. Try solving. So the minimum distance between object and real image for the concave mirror is. So when you have a concave mirror, what is the minimum distance? When you have a concave mirror, now do you remember the ray diagrams for the concave mirror? There is a concave mirror. There is a principal axis. When the object is at infinity, image will form at the focus. So the distance between object and focus is going to be infinite. So let's write down here the object, then the image location and the distance between them, like a difference, which is object distance minus image distance, and you take the positive value of it. When the object at infinity, image at focus, the difference between these two is infinite. Then when you bring the object closer, so object between, let's suppose there is a focus, there is a center of curvature, object is beyond C. When the object is beyond center of curvature, image will form between C and F. Okay, let's not calculate the difference. We'll come back to that. Then you bring the object even closer, object at C, image at C. So what is the difference? Difference is 0. Okay, now this difference between this point and this point is greater than 0. So this distance is greater than 0. Clear? The next one, when you bring the object even closer, object is between C and F, image is beyond center of curvature. Again the distance is greater than 0. When you place the object at focus, image would be at infinity and difference will be infinite. So what is the minimum location or minimum distance between object and real image? So these are all real images and the minimum distance between them is going to be 0. That is the right answer. Clear? Easy? You can type your answers if you find it. Alright, let's solve this. Is this clear? Is that question clear? Any questions? All clear? Nice, positive, all. Rakshana, Niharika, Anshul, Patil. Alright, great. Nice. Let's solve this question. So we have a convex mirror here and there is a focal length. It produces image at a distance of 10 cm from the pole. There is a convex mirror. So when you have a convex mirror, does it form real image or virtual image? What do you think? You have a convex mirror here. There is a convex mirror. When you place the object, so this is the object, and if you have a convex mirror, image is always going to be virtual image. So this is the image. Okay. What is the focal length? This is the focal length. Focal length of a convex mirror is 20 centimeter. Okay. You don't know the meaning of the focal length? Then you should watch my earlier videos. Kapil Chauhan. Focal length is nothing but the distance between pole and the principal focus. So this distance is called as focal length. Okay. Real image? No. The convex mirror never forms a real image. It is always going to be virtual. Right. So now what are the given points? The focal length is 20, but there is a convex. So focal length is going to be positive. So focal length is plus 20 centimeters. Now it produces image at a distance of 10 centimeter from the pole behind the mirror. You see the image is behind the mirror. So that means this is our V. V is the image distance. So V is also going to be positive plus 10 centimeters. So what is this ask? What should be the object distance? So this distance U that you have to calculate. So what is U? That is a question. Virtual and erect. Nice. Loafer gamers. Correct. And how will you get this? There is very simple unique equation. Do you remember? Just now I told this equation. This one. Very important equation. If you are in grade 10, lot of questions will come based on this equation. Very important equation. Mirror formula. Yes. So let's use that. So what is the equation? 1 by V plus 1 by U is 1 by F. We want to calculate U, right? So 1 by U is nothing but 1 by F minus 1 by V. So what is the focal length? Focal length is plus 20. So 1 divided by 20 minus 1 divided by 10. This is plus 10. Okay. So let's find out. So the LCM of 20 and 10 is 20. So this is 1 minus 2, which is minus 1 by 20, which is 1 by U. Right. So from here, what is the value of U? U is going to be minus 20 centimeter. That is our answer, which is option number A. And you see here, this value of U is negative. It has to be negative because U is on the left of the pole. So value of U has to be negative. Easy, right? Hello Sahil, Niharika, positive all. Yeah, it's okay, positive all, it happens. Easy question. Let's solve one more. Solve this question. So what is the question? Distance of the object from a concave mirror. There is a concave mirror. So whenever you get a question on the mirrors or lens, you should draw the ray diagram. That is better. Draw the rough ray diagram. You don't have to draw perfect ray diagram, but you can draw rough ray diagram. So there is a concave mirror. Can you see? Concave mirror. And what is given? The distance of the object. So let's suppose there is an object here. And this would be our U. From the concave mirror is 4 times the focal length. Now, what is the focal length? There is a focus, there is a pole. So this distance is the focal length. So both U and F, both of them are negative. You remember, the focal length for the concave mirror is negative. Even the U is negative. So we can write U is equal to 4 times F. Okay? Between C and F. Nice AR gamer. So what we want to find out? Position of the image will be. Yes, that is correct, right? What is the position of the image that you have to calculate? And how will you find out? So now, if the object is 4 times the focal length, that means, okay, now I'll draw the bigger image. So there is a focus, there is a center of curvature, there is a pole. So this length is F. This length is 2 times F. An object is somewhere here. There is an object which is at a distance of 4 times F. So now object is placed beyond C. If you place the object beyond C, where will be the image? So image will form here. This would be the image. So what are the properties of this image? It is forming between C and F. That is the position of the image, right? Image is formed between C and F. Then it is a real image. There is an inverted image. Can you see? There is a vertical inversion. Real, inverted and diminished image. So these are the properties of the image. Clear? Easy question? Yes, nice AR gamer. You are right. Awesome. Great. Solve this. Solve this question. Okay, so what is the question? Rays from the sun. The rays, they are coming from the sun, converge at a point 15 centimeter in front of a concave mirror. So when you have a concave mirror, is a concave mirror. So the rays are coming from the sun. Sun is the object which is at infinity. So there is an object at infinity. There is our sun, right? So the rays coming from the sun are going to be rays which are parallel to the principal axis. So they will fall on the mirror and they will converge at this point. This we know as a focus, right? So what is it said? The rays from the sun converge at a point 15 centimeter in front of a concave mirror. So this distance is 15 centimeter. So what do we know now? We know that the focal length is 15 centimeter. Right? Nice gamer. Awesome. Yes. So where should the object be placed so that the size of the image is equal to the size of the object? So when do we get the size of the image same as size of the object? When you place the object at the center of curvature. You have to place the object at center of curvature. So what is this distance? From the pole to the center of curvature, there is a 2 times focal length, right? This distance is nothing but radius of curvature. So radius of curvature is nothing but 2 times the focal length. And what is focal length? 15. So there is 30 centimeter. There is a focal length. Focal length is 15 centimeter. So 2 times the focal length is 30 centimeter. So where should you place the object? Object should be placed at the center of curvature. That is nothing but 30 centimeters in front of the mirror. That would be your right answer. Clear? Easy? Easy, right? How many of you find it very easy, very simple? जल्दी में गलत हो गई, कोई नहीं. Easy, right? Nice. These are very easy questions. You just have to focus. So what you should do is draw the rough ray diagram. This is a rough ray diagram. So if you can draw a simple rough ray diagram, then it would be very easy to solve such numerical questions. They are not difficult, but we get confused. We first don't draw this, and secondly, the sign convention. At the beginning, I spent like 5-10 minutes in explaining what is the sign convention. That is super important. You should again go back and watch that part. Alright? So that's it for today. Thank you so much everyone. Bye bye. Enjoy. See you again in the next class. In the next class, we are going to solve more difficult questions from that mirror equation. And there is one more thing, which is a magnification. So we are going to solve a lot of numerical questions in the next class. So see you again next week. Bye bye. Take care. Enjoy.